Every comet we have charted until now has obeyed the universe's choreography. Ice boils into vapor, trails bloom behind, dust and debris scatter in a predictable wake. Then came 3I Atlas, a renegade that ignored the script. Instead of glowing in its tail, it lit the space ahead, a phantom lantern burning against expectation. No gases, no signature chemistry, only a brilliance that mocked its supposed size. A natural fluke? The probability drops to near nothing. And that improbability leads to a troubling hypothesis. What if the strangeness is intentional? What if 3I Atlas is designed to be unmistakably artificial, a galactic postcard daring us to notice? Picture it not as a comet, but as a puzzle. Tonight, we unravel how this wanderer might be the ultimate Turing test, only the subjects are not machines, but us. Humanity itself placed under quiet evaluation. Before we proceed, hold this question in your mind. If we are the examinees rather than the examiners, would we even realize the test has begun? The date is the 1st of July, 2025. Astronomers detect something that should not exist. A body appears in our telescopes, a masquerade in Comet's clothing, yet it refuses to perform the roles assigned by physics textbooks. It shines forward, not backward. It carries no plume of evaporating ice, and its path calculated with precision that beggars belief threads the inner planets as if rehearsed. A natural explanation teeters on the edge of mathematical impossibility, and still, our institutions call it a comet. That stubborn label conceals a paradox, one that echoes an intellectual challenge posed long before. In 1950, Alan Turing framed his famous question, could a machine pass as human through conversation alone? The genius of the test was not about machinery, but about recognition. Could we see intelligence when it chose to wear a disguise? Now imagine that principle writ large, not code behind a terminal, but civilizations behind a mask of stone. A rock behaving like no rock should. The real test is ours. Can we recognize intelligence when it arrives hidden in plain sight? 3I Atlas forces this riddle upon us with unsettling immediacy. Fail to solve it, and perhaps we are judged as not yet ready, our species written off as blind to the obvious. The stakes, unspoken yet immense, may determine whether we are welcomed into a broader galactic fellowship or remain confined to our provincial silence. History warns us against hubris. In 1794, Ernst Chladni dared to claim that meteorites fell from space. His peers laughed. Rocks from the heavens? Absurd. Only decades later, after thousands witnessed a fiery fall in L'Aigle, France, did consensus admit the obvious. We flatter ourselves that we have grown wiser, more open to disruptive truth. But the past few decades suggest otherwise. In 2017, ʻOumuamua crossed our skies, an interstellar visitor with acceleration no natural cometary process could explain. Instead of wonder, most scientists chose comforting fictions. In 2020, another object revealed itself to be artificial space debris. Yet until the last moment, it too was mistaken as natural. That should have humbled us, taught us that the masquerade can work both ways. But when Atlas arrived, the lesson evaporated. Once more we reached for the familiar label, Comet, while evidence whispered otherwise. Each anomaly dismissed, each contradiction explained away, forms a kind of curriculum, a progression of tests escalating in visibility, as though someone is gradually raising the volume of a cosmic signal. Do we notice yet? Do we dare admit what the evidence implies? One voice has consistently pressed the uncomfortable questions. Dr. Avi Loeb, Harvard astrophysicist, has refused to treat anomalies as curiosities to be shelved. He reminds us of Chladni's lonely defiance centuries ago, challenging colleagues to strip away illusions. Loeb insists that the emperor may indeed be unclothed. His persistence embodies intellectual courage at a time when dismissal is easier. Yet there is a crucial difference between Chladni's era and ours. The clock is ticking. If 3I Atlas is a midterm exam administered by unseen observers, then our reaction becomes the grade. Are we open to radical possibility, or do we cling to improbable coincidences that protect fragile orthodoxy? Look closer at the numbers. Atlas follows a retrograde orbit, aligned against the solar system's gray nodes near zero. It brushes past Mars, Venus, Jupiter, its timing uncannily exact again, improbability stacked upon improbability. Its brightness implies a size 20 kilometers across, a rarity that should visit once every 10,000 years. These are not quirks, they are red flags snapping in the void. Yet the word comet is repeated like a mantra, protecting consensus from rupture. This reflex reveals something about us. Humans hunger for patterns, but we cherish those that validate our beliefs. When reality dares to present patterns that undermine them, blindness is the easier choice. We accept what feels safe, deny what demands revolution. So here we stand, confronted by a glowing question mark written across the sky. If 3I Atlas is more than ice and dust, then perhaps it is a mirror. It shows us not only the possibility of other minds, but also the limits of our own. The haunting question remains: when intelligence hides inside the ordinary, are we capable of recognizing it before the opportunity vanishes into the dark? If this is a test, then we must ask the question no scientist wants to put on record: who sent it? And even more unsettling, are they still watching? The implications spill far beyond astronomy into the heart of our self-image as a species. If 3I Atlas is an exam paper drifting through our skies, then it does not measure orbital mechanics or spectroscopy alone. It measures curiosity. It measures courage. It measures whether we can let go of comfortable assumptions when confronted with impossible evidence. Our reaction becomes a mirror, reflecting the maturity or immaturity of human intellect. Are we ready to accept the possibility that we are not alone? Are we prepared to imagine neighbors who approach with subtlety rather than spectacle, who test our wisdom rather than our weapons? Science fiction has trained us to expect motherships and flashing lights, not riddles hidden in celestial mechanics. Yet an intelligence advanced enough to cross interstellar space would surely be clever enough to design tests that challenge not our technology, but our discernment. What follows is not merely astronomy, but a confrontation with our own readiness. The investigation begins with the impossible visitor itself, the comet that is not a comet, the glowing paradox of 3I Atlas. But before diving into its anomalies, a warning. The story you are about to hear may fracture the most comforting illusion we carry, that the universe is silent, indifferent, and populated only by rocks and gases. This narrative does not offer that safety. If the interpretation is correct, the test has already begun. And the only question remaining is, are we self-aware enough to recognize that we are sitting in the examination hall? On the 1st of July, 2025, the Hubble Space Telescope, an aging sentinel that has outlived generations of its operators, captured images of something that should not exist. At first glance, astronomers breathed easily. The object appeared comet-like, a hazy cloud, a faint coma, familiar to any graduate student pulling midnight observation duty. Another visitor? Yes. Interesting? Yes. But nothing to disturb dinner plans. Then came the closer look. The coma was in the wrong place. Instead of trailing behind as every comet has ever done, the dust plume was ahead of the object leading, not following. Imagine a candle flame bending against the wind. A comet's tail is physics 101. Sunlight strikes the ice, molecules sublimate, The gas and dust stream away from the Sunday predictable, reproducible textbook. But this object seemed to be consulting a different textbook altogether. Spectroscopy compounded the mystery. Every comet humanity has ever examined leaves a chemical fingerprint, water vapor, carbon monoxide, volatile gases unraveling from its icy heart. These signatures are as fundamental to cometary identity as DNA to a species. Yet 3I Atlas showed none. Not reduced traces, none. Zero. A dust cloud with no chemistry to support it, a glow without fuel. It was an actor miming the lines of a comet without ever speaking them. Brightness added another layer of improbability. Its apparent magnitude suggested an object roughly 20 kilometers across if it reflected light like an ordinary comet. But interstellar objects of that size should arrive perhaps once in 10,000 years. And here it was, in the fleeting century when human beings possessed telescopes sharp enough to see it. Coincidence of staggering magnitude, or a design tuned precisely to be noticed. Then came the orbital analysis, and with it the sense of impossible choreography. 3I Atlas moved retrograde against the general traffic of the solar system. Not impossible, but rare to the tune of about 0.2%. Unlikely, but survivable by chance. Yet its orbit lay aligned almost perfectly with the ecliptic plane, where the planets dance in their ancient circle. That alignment, too, carried a probability of about 0.2%. Rare, but not impossible. But the timing, oh, the timing. Atlas's path brushed Mars, Venus, and Jupiter in sequence, like a cosmic baton tapping planets on the shoulder. The precision resembled the output of a navigation computer rather than the accident of celestial drift. The odds of such timing occurring naturally, about 0.005%, 1 in 20,000. And that estimate assumes the absence of the other improbabilities already stacked beneath it. Each unlikely event was not isolated, but cumulative, forming a structure of unlikelihoods as precarious as a house of cards balanced in a gale. And yet, the chorus from the scientific community was uniform. A comet, definitely a comet. Strange, yes. Odd, yes. But still natural. As the anomalies piled up, so did the rationalizations. Perhaps unfamiliar sublimation physics, perhaps exotic dust mechanics. The explanations grew inventive, elastic, stretched thin across the surface of improbability. History, once again, whispered its cautionary tale. In 1957, Sputnik's radio pulse echoed across Earth. To those with antennas and knowledge of Doppler shift, its artificiality was unmistakable. A voice from human ingenuity had taken orbit. But imagine a culture without radios. To them, the beeps might have been dismissed as atmospheric noise, lightning trapped in the ionosphere, anything but technology. Recognition of artificiality depends not on the signal, but on the listener. It depends on context, on the willingness to consider what seems impossible. And so the unsettling parallel emerges. 3I Atlas may be speaking in a language we have not yet learned to interpret. Its anomalies may be a structured message, not random quirks. But like the hypothetical radio-deaf civilization listening to Sputnik, we risk dismissing the artificial as natural, simply because our paradigm lacks the vocabulary to name it. The question, then, is not whether 3I Atlas is a comet. The deeper question is whether we are capable of recognizing when a mask is being worn, when the familiar hides the extraordinary. If this is indeed a test, the examiners will not grade us on our ability to compute orbital elements or run spectrographs. They will grade us on our willingness to question, to doubt, to stretch, to acknowledge that the universe may be more cunning than we imagined, and somewhere, Perhaps in the dark beyond our instruments, eyes may be watching, not for the comet itself, but for our reaction to it. The object that arrived in our skies should have set off every alarm in the arsenal of scientific detection. Its behavior defies expectation. Its characteristics mock our textbooks, yet we keep forcing it into the same familiar box, a comet. Why? Because the alternative, that we may be watching technology instead of geology, feels too destabilizing to entertain. The treatment of 3I Atlas by the mainstream scientific community reflects a peculiar conservatism of the mind. Faced with data that will not fit, the instinct is to bend the data, not the theory. It must be a comet, because comets are known. That it behaves like no comet we have ever encountered becomes an afterthought, something to rationalize away rather than confront. This instinct, this intellectual self-preservation, is not malicious. It is how normal science operates. Progress through steady accumulation within existing paradigms. But it fails when reality refuses to cooperate. Paradigm shifts require those rare individuals willing to take anomalies seriously, to risk reputation by suggesting that perhaps our foundational assumptions need revision. In the case of 3I Atlas, Dr. Avi Loeb has stepped into that role. His suggestion that we consider an artificial origin was met with the kind of skepticism that always greets paradigm-challenging ideas. Too speculative, too extraordinary, too far beyond respectable inquiry. But perhaps respectability itself is the problem. Respectability binds us to convention. Respectability blinds us to what might be obvious. The arrival of this impossible object on the 1st of July, 2025, has placed us before a fork in the road. Do we choose comfort or evidence? Do we continue to cling to familiar explanations, or do we admit the possibility that intelligence might be disguised as stone? Our response is not neutral. If 3I Atlas represents an evaluation, then how we interpret it becomes part of the test. The question is stark. Are we capable of recognizing the artificial when it hides behind the natural? Can we separate what we wish to be true from what the evidence insists? The answer may decide not just the interpretation of one object, but the trajectory of our species. History provides a sobering reminder of how often we fail this very test. The year is 1794. Ernst Chladni stands before the European scientific establishment and suggests that meteorites fall from space. The response is swift and merciless. Laughter, ridicule, ostracism, stones from heaven. Impossible. Where would they come from? How could they travel? The very idea is heresy. For nearly a decade, his claim is a joke whispered in lecture halls. Then, in April of 1803, the sky explodes above L'Aigle, France. Thousands witness the fireball. Stones rain from the heavens, still warm when picked from the ground. Jean-Baptiste Biot investigates, confirms their extraterrestrial origin, and forces an entire scientific community to swallow its scorn. What was once absurd becomes undeniable. Reality had refused to bend to expectation. This pattern, the rejection of the anomalous until it becomes overwhelming, haunts the history of science. When data challenges our worldview, our first reflex is dismissal, not curiosity. The anomaly must be wrong. The instruments must be faulty. The observer must be mistaken. Anything but the terrifying possibility that our mental models might need replacement. 2 centuries later, the same story plays out again. 3I Atlas delivers data that defies every comfortable category, yet the community responds with the same reflexive denial. It must be a comet, not because it behaves like one, but because comets we understand, while probes we fear to admit. And the roll call of similar episodes is long. Ignaz Semmelweis discovered that hand-washing reduced mortality in maternity wards, only to be ridiculed into despair. Alfred Wegener proposed continental drift decades before plate tectonics was accepted, enduring a lifetime of dismissal. Again and again, the pattern repeats: anomalous data, ridicule, eventual capitulation to reality. But with 3I Atlas, the stakes are different. Chladni had time, Wegener had decades. Here, the clock may already be running out. If the object is part of an evaluation or a quiet attempt at contact, then our window for meaningful response may be brief. We cannot afford the luxury of generational delay, and the mathematics should unsettle anyone willing to confront them. The trajectory of 3I Atlas is not just improbable, it is effectively impossible. Retrograde orbit, near-perfect alignment with the ecliptic, planetary encounters timed with the precision of a celestial navigator, brightness that suggests an object so large it should appear once in 10 millennia, yet it arrives in the single century when human instruments can observe it. These are not quirks, they are signals, loud as thunder, yet our explanations grow ever more elaborate in order to preserve comfort. Exotic sublimation models, dust dynamics stretched beyond credibility. It is like watching someone stare at lightning and insist it cannot be electricity because they are not ready to accept that the sky itself can generate power. The denial is not born of evidence, but of fear. Benjamin Franklin once faced this same resistance. His proposal that lightning and laboratory sparks were manifestations of the same force seemed absurd to the establishment. Sparks were parlor tricks. Lightning was a meteorological curiosity. To connect them was to violate intellectual categories. But Franklin dared to fly a kite into a storm, and the sky answered with electricity. 3I Atlas may be demanding of us the same daring leap. To fly the metaphorical kite, to risk the jolt of revelation, to accept that sometimes the extraordinary is not fantasy but fact. The only question is whether we will meet the challenge or whether, once again, history will record that reality had to drag us, protesting, into its wider truth. Franklin's kite experiment and 3I Atlas could not be more different in setting or scale, and yet the principle that binds them is identical. Franklin's willingness to risk ridicule and lightning alike allowed him to interpret anomalous data as something more than noise. He saw a clue to the universe's hidden logic. That act of intellectual courage cracked open the modern science of electricity. Today's astronomers face their own thunderstorm moment in the skies above. 3I Atlas. They can either continue to conjure increasingly improbable natural explanations, or they can stand in the storm with kite and key and admit the evidence whispers of something else. The choice determines whether we replay the old story of delayed recognition or finally learn to embrace anomalies as opportunities for transformation. The stakes this time extend far beyond academic careers or professional reputations. If 3I Atlas is more than a comet, if it is a test designed to probe our willingness to recognize intelligence in unfamiliar forms, then our handling of it reflects the intellectual maturity of our entire species. The question is not just scientific, it is existential. Do we learn from our history of mistakes, or are we doomed to repeat them, even when the outcome could decide whether we are welcomed into cosmic company? The tragedy of scientific conservatism is that it delays precisely the breakthroughs anomalies demand. When reality presents data that does not fit, our reflex should be excitement. Anomalies are gifts, portals to discovery. Yet our institutions reward conformity. Graduate students quickly learn that careers are built on safe projects within accepted paradigms, not dangerous ideas that might topple them. Senior scientists guard their reputations by shunning speculation. The result is systemic blindness. A culture superb at normal science but clumsy at paradigm shifts. The historical record is clear. Chladni was not a planetary scientist when he dared to suggest meteorites fell from the sky. He studied acoustics. Franklin was no academic physicist, but a printer, statesman, and tinkerer when he revealed electricity's unity with lightning. Outsiders, less invested in orthodoxy, often see what the insiders cannot. Dr. Avi Loeb stands in that lineage. His willingness to propose artificial origins for anomalous interstellar objects is the very kind of speculation that sparks revolutions. Yet his peers dismiss him, protecting professional respectability over the unsettling possibility that he may be right. The question is whether we can escape this historical loop. Will 3I Atlas become another Lagle moment, an obvious truth denied until the evidence piles too high? Or will we prove, for once, that we have evolved the intellectual flexibility to recognize intelligence when it wears an unfamiliar mask? History itself has become our examiner. Our response will show whether we are prepared to graduate from provincial science to cosmic dialogue. The rocks are still falling from the sky, only now they fall from between the stars. Whether we treat them as stones or signals may be the most consequential decision humanity makes in this century. The test continues, and the clock does not stop. But 3I Atlas is not the first messenger to confront us with this exam. We rewind to the 19th of October, 2017. The Pan-STARRS telescope in Hawaii records something unprecedented, the first confirmed interstellar visitor. It is named ʻOumuamua, messenger from afar arriving first. The name, poetic in the Hawaiian tongue, proved prophetic. The object was unlike anything in our catalogues. Where asteroids and comets are squat and irregular, this visitor was elongated to an absurd degree. Cigar-shaped, perhaps pancake-flat, its aspect ratios stretched between 5:1 and 10:1. Nothing in our solar system looks like this, but its shape was only the opening act of the anomaly. As ʻOumuamua swung around the sun and began its outbound journey, astronomers noticed something that should not have been possible. It was accelerating, not simply coasting along the curve gravity dictated, but pushed, ever so slightly, by some invisible hand. Comets do this, yes, but only because sublimating ice vents, jets of gas. That natural rocket effect is well understood. And yet ʻOumuamua showed none of the telltale signs. No water vapor, no carbon monoxide, no glowing tail. Nothing. The community faced an uncomfortable binary. Either ʻOumuamua was a natural object of a type never before seen in billions of years of solar history, or it was something artificial, a construction, not an accident. Dr. Avi Loeb dared to ask the forbidden question: what if ʻOumuamua was a solar sail? What if radiation pressure from sunlight, not jets of ice, explained its acceleration? The idea ignited debate like dry tinder meeting flame. His colleagues dismissed it as too speculative, too extraordinary. The object must be natural, they insisted, because artificiality was too uncomfortable to admit. And yet the anomalies refused to vanish. Oumuamua's spin was chaotic, tumbling in ways that suggested either strange geometry or structural damage. Its brightness shifted dramatically, hinting at surfaces unlike any known body. Most unsettling was its past. Tracing its trajectory backwards, astronomers found no origin star system, no ejection event. It was genuinely nomadic, wandering for millions of years through interstellar dark. Placed in that context, the solar sail hypothesis gained unsettling traction. A fragment of technology adrift between the stars, propelled only by light. A messenger indeed, and perhaps, as the name foretold, the first of many. Seen against this background, 3I, Atlas, is not an isolated riddle, but the next page in a curriculum. Each visitor stranger than the last, each anomaly more blatant, each coincidence more impossible. The signal grows louder, the exam grows clearer. The only question is whether we, the students, have learned enough to recognize the lesson. An interstellar probe designed by intelligence would need to look almost exactly like ʻOumuamua. Its improbable elongation, far beyond the proportions of any asteroid or comet we know, hints at extreme structural efficiency, precisely what you'd want for a craft built to endure million-year journeys through the vacuum. Its unexplained acceleration away from the sun could be accounted for by radiation pressure on a broad, thin surface, an elegant alternative to carrying fuel across the stars. Autonomous navigation, course corrections without visible exhaust, a silent persistence through interstellar dark. All these traits converge uncannily with what human engineers themselves have begun sketching in theory. The parallels are striking enough to make denial feel less like skepticism and more like willful blindness. History gave us rehearsal cases. In 2020, an object dubbed 2020 SO was discovered by ground-based telescopes and promptly classified as an asteroid. Only after painstaking orbital detective work did NASA confirm it was, in fact, a Centaur rocket stage from a 1966 lunar mission still circling the sun after more than half a century. Artificial debris had slipped into the wardrobe of a natural object, and our detection systems were fooled even though the technology was our own, launched from our own Earth, and described in our own records. If we can misidentify our own artifacts, how much easier would it be to miss the handiwork of a civilization older, subtler, and unimaginably more advanced? The Tesla Roadster offers another parable. Launched into space by SpaceX in 2018, Elon Musk's cherry-red car, complete with a mannequin driver and Bowie's Times, Space Oddity, Times, playing on repeat, was meant as a publicity stunt, a piece of theater. Yet, within months, telescopes catalogued it as an unidentified object. To those unaware of its launch, it looked like space debris, maybe even a small asteroid. Its tumbling spin, unusual reflectivity, and unpredictable perturbations only deepened the confusion. Here was a car mistaken for a rock. In a sense, it became humanity's first unintentional demonstration that artificial objects can masquerade as natural ones, and vice versa. Together, these episodes form a sobering precedent. We know artificial objects can trick our classification systems. We know we are vulnerable to misidentification, even with full access to the launch logs and engineering blueprints. So why, when presented with ʻOumuamua, an interstellar visitor displaying characteristics perfectly aligned with what an artificial probe might require, did we insist it had to be natural? Because the alternative was too disruptive? Because the cost of considering the possibility was judged higher than the cost of clinging to an explanation that did not fit? Yet the very ambiguity may have been the point. If a civilization wanted to observe us without disturbing us, their probes would not announce themselves with neon signs. They would masquerade as stones, shadows, comets. Their camouflage would be subtle enough to allow dismissal by the incurious, but provocative enough to test whether any among us could pierce the disguise. ʻOumuamua arrived at precisely the right moment when humanity was just learning to scan interstellar space seriously. It pushed the boundaries of natural explanation without crossing so far into the artificial that it forced consensus. In retrospect, it looks almost pedagogical. The first lesson in a curriculum designed to measure our intellectual flexibility. The response to ʻOumuamua revealed exactly what observers might want to know. Scientists trained in caution defaulted to natural hypotheses, however strained. Anomalous acceleration without gas emissions? a new kind of ice. Extreme proportions unlike anything else? Coincidence? Each explanation bent to preserve orthodoxy. Meanwhile, a smaller chorus of voices, led by Dr. Avi Loeb, dared to ask if the simplest explanation was also the most extraordinary, that it might be technology. Their marginalization revealed just how heavily professional respectability weighs against speculative imagination. And yet, outside the journals, something remarkable happened. The public was captivated. ʻOumuamua made headlines, inspired artwork, filled forums and conversations with wonder. People instinctively sensed it was different, unprecedented. Unlike another routine comet, it carried the aura of messenger, its Hawaiian name all the more prophetic in hindsight. This grassroots fascination suggests that our species has not entirely lost the capacity for wonder. Even as institutions shield themselves with skepticism, ordinary minds remain open to the extraordinary. Perhaps that too was part of the exam, to see whether curiosity, unmediated by career or consensus, could still thrive. ʻOumuamua slipped back into interstellar dark, tumbling away with its secrets. But it left behind more than questions. It proved that visitors from other stars do arrive, that they can display characteristics unaccountable by natural categories, and that our response exposes our deepest strengths and weaknesses. The messenger delivered its message, whether or not we admitted it. The curriculum did not end there. On the 11th of February 2018, the Falcon Heavy rocket roared off the pad at Kennedy Space Center, carrying its whimsical payload, the Tesla Roadster. For weeks, telescopes tracked it, and many who hadn't followed the launch classified it as an asteroid. Again, the same lesson, the ease with which the artificial can pass as natural. Then, on the 17th of September 2020, came another chapter. NASA's Catalina Sky Survey flagged an object on an unusual trajectory. It was designated 2020 SO. Its orbit was neither convincingly natural nor comfortably artificial. Spectroscopic hints suggested metal rather than rock. Its spin matched manufactured materials. Its path traced suspiciously close to Earth's history of launches. NASA's Jet Propulsion Laboratory conducted orbital archaeology, rewinding decades of gravitational perturbations, solar pressure, planetary nudges, until at last the culprit was found. It was indeed a rocket booster, a relic of a 1966 lunar mission, slowly spiraling home after more than half a century. What did these episodes teach us? That the line between natural and artificial in space is perilously thin. That ambiguity is not an exception but a constant. That even with our own machines, our own data, and our own context, we can be fooled. And so, when ʻOumuamua presented itself, the case for artificiality was not wild fantasy, but sober precedent. It displayed exactly the traits one would design into an interstellar probe. It arrived at precisely the moment our instruments became capable of noticing, and it exposed, with clinical precision, the psychology of our response, the reflex to dismiss, the hunger for comfort, and the enduring spark of wonder among those who dared to imagine. The messenger came, it left, and the question it asked remains hanging in the silence it left behind. Will we be ready for the next one? On the 20th of November 1966, the Centaur upper stage of the failed Surveyor 2 mission slipped unnoticed into the silence of heliocentric orbit. For more than half a century it wandered, a polished aluminum relic adrift in the solar system, its skin gleaming under sunlight, its course imperceptibly bent by the faintest of forces. Solar radiation pressure, decade after decade, photons nudged it, reshaping its orbit until at last, in 2020, the wayward booster returned home. It was catalogued at first as an asteroid 2020 SO until painstaking detective work revealed its true origin. The irony was exquisite. A piece of human space junk had become a perfect demonstration of the very physics that Dr. Avi Loeb invoked to explain Oumuamua's mysterious acceleration. Here, in aluminum and steel, was proof that radiation pressure alone could mimic the propulsion once thought impossible. What had been dismissed as too extraordinary for an interstellar visitor was quietly admitted when the culprit was recognizably human. The lesson is not subtle. If our own rocket stages can fool our instruments for months, exhibiting precisely the anomalies we deemed impossible for Oumuamua, then perhaps the problem lies not in the data, but in our selective willingness to interpret it. The Tesla Roadster taught us the same thing in 2018. Musk's car, lofted into solar orbit, immediately blurred categories. Those who knew the launch story recognized it as a stunt. Those who didn't saw something baffling, a tumbling object with unusual spectra, easily mistaken for a natural body. Context made all the difference. Without the backstory, the object was ambiguous. With it, artificiality was obvious. The same applied to 2020 SO. Only by tracing its orbit back through decades of gravitational perturbations could astronomers tie it to the Surveyor 2 mission. Suddenly, the mystery collapsed into familiarity. This dependency on context exposes a profound weakness in our detection frameworks. We are adept at identifying human technology because we know its story. We understand rocket stages and Teslas because we built them. But how would we recognize technologies we didn't invent? How would we interpret artifacts crafted by minds thousands or millions of years ahead of us? To an observer from the 18th century, a smartphone would seem like magic or miracle, utterly outside comprehension. So too might probes from older civilizations appear to us as mere rocks because we lack the conceptual vocabulary to decode their design. The selective application of physics betrays our own discomfort. We are content to accept radiation pressure as the driver of non-gravitational acceleration when the object is a Centaur rocket, but recoil from applying the same reasoning to Oumuamua. The laws of physics should not change depending on whether the artifact is ours or theirs. Either radiation pressure is sufficient or it is not. Yet our interpretations bend around our psychological comfort zones, not around the evidence. There is also the archaeological dimension. Objects like the Roadster and the Centaur stage will persist in solar orbit for millions of years, long after our cities crumble. Future observers, whether alien archaeologists or distant descendants of our own species, may stumble across them and puzzle over their meaning. Imagine the interpretive riddles. A mannequin in a spacesuit behind the wheel of a fossilized car, red paint faded but still clinging. A booster stage gleaming like an ancient urn, scarred by micrometeoroids. These would become clues to a vanished civilization's technology, values, and peculiar humor. If Oumuamua and now 3, Atlas are artificial, they may be exactly that. Archaeological artifacts drifting between the stars. Their makers might be extinct, leaving only these wandering monuments. Or they may be alive, quietly watching how we interpret the clues. Either way, the lesson from our own false alarms is unavoidable. Space is already littered with artifacts, artificial objects masquerading as natural ones. Our reluctance to recognize them when the fingerprints aren't human says more about our psychology than about the universe. And so the curriculum continues. Oumuamua gave us impossible acceleration without explanation. Our own technology, Roadster, Centaur, proved beyond doubt that artificial objects can slip into disguise, tricking us until context rescues the truth. And now comes 3I Atlas, its anomalies so pronounced that even our most creative rationalizations strain under the weight. Each lesson is louder than the last, Each false alarm is a test in humility. The question is whether we are learning, or whether we are simply rehearsing the same mistakes, clinging tighter to old explanations even as the evidence tears them apart. The universe appears to be administering an escalating curriculum, one anomaly at a time. We passed the practice questions eventually, recognizing our own technology once the clues were overwhelming. But the final exam may already be underway, and unlike the practice tests, this one will not grant us the answers in time to revise. Which brings us back to 3i Atlas. Let us dissect the impossible. It glows ahead of itself, not behind. It resists cometary chemistry. Its brightness and size defy statistical expectation. Its orbit and timing flirt with impossibility. Each anomaly, standing alone, is strange. Taken together, they form a pattern so extreme that coincidence theory collapses under its own weight. This is not simply a rock in space. This is the backwards glow that starts the next chapter of the story. Every comet humanity has ever observed has followed a script so familiar it feels almost ritual. The sun warms the nucleus, frozen ices sublimate into gas, and solar radiation together with the solar wind sweeps dust and vapor outward. A comet's tail is always obedient, always streaming away from the star. Never forward, never against motion, always awake, never a headlight. And then came 3i Atlas, glowing in defiance of every law we thought immutable. Its plume did not trail, it led. A dust cloud preceding it like a cosmic lantern, illuminating the path ahead instead of marking the path behind. This is not some minor quirk in measurement, not an artifact of instrumentation. It is a fundamental violation of cometary physics, the equivalent of watching smoke from a fire poured downward instead of upward. To preserve natural explanations, astronomers have proposed exotic sublimation processes that would somehow eject dust only from the object's leading edge while leaving the trailing side inert. But such dynamics exist nowhere in our models. They require atmospheric conditions that have no precedent in solar system science. The mystery deepens when we tune our instruments to listen for chemistry. A real comet sings a molecular song. Water vapor, carbon monoxide, carbon dioxide, volatile gases liberated by heat. Each has distinct spectral lines as recognizable as fingerprints. But 3i Atlas is silent. No water, no volatiles, no molecular signals at all. Its dust cloud exists without the gas dynamics required to create or propel it. By the rules we know, that is impossible. Sublimation cannot occur without byproducts. Dust cannot be lofted without escaping gases. And yet here is an object that manages both impossibilities simultaneously. Brightness compounds the enigma. Based on its light curve, and assuming a comet's typical charcoal dark albedo, 3i Atlas must be roughly 20 kilometers across. That is an interstellar leviathan. Statistics tell us we should encounter such a visitor perhaps once every 10,000 years. Yet it arrives now, in the half-century when our species possesses the instruments to notice. A window so narrow, it occupies less than a fraction of a percent of human history. The coincidence is staggering. Either nature has performed an improbable trick, or intention has guided timing, and timing is only one layer in a lasagna of improbability. The trajectory reads less like chance and more like choreography. The object threads its way through the solar system in a sequence of gravitational interactions worthy of a NASA mission design. Mars, Venus, Jupiter, each flyby positioned with precision that would make a navigation computer proud. The probability of such planetary encounters occurring by accident, around 0.0005%. Imagine throwing a dart blindfolded at a map of the United States and striking not just a city, not just a building, but a specific room. The odds of 3-1 Atlas's path are comparable to that impossible precision. And then there is its orientation. Retrograde, moving backward against the rotation of the solar system, yet aligned almost perfectly with the ecliptic plane where our planets orbit. Random interstellar visitors should scatter in from every direction, bearing random tilts. The chance of achieving this specific combination retrograde, plus planar alignment plus planetary encounters, is the product of independent improbabilities. Each slim percentage multiplies into vanishing likelihood. What emerges is not a single statistical outlier, but a tower of impossibilities, nested like Russian dolls. Even attempts to simulate the dust dynamics produce absurdities. Models suggest the object would need to shed a layer of millimeter-thick dust across its leading edge over a period of 6 months, while leaving its trailing side strangely untouched. That alone has no analogue in cometary science. Worse, it must accomplish this shedding without any of the sublimation chemistry that powers dust release in known comets. Dust without gas, surface erosion without molecular weathering, sustained activity without an energy source. We are asked to believe in physics with no precedent, explanations that collapse under their own contradictions. But shift one assumption, and clarity emerges. Suppose the surface is not the dull black of a comet, but highly reflective, mirror-like. Suppose it gleams with manufactured efficiency, its albedo engineered for thermal or optical purposes. In that case, 3I Atlas could be far smaller than 20 kilometers, yet still blaze with its observed brightness. Such reflectivity would be entirely consistent with technology, not geology. And yet to acknowledge this requires surrendering the comfort of familiar categories. The timing of its arrival raises questions that cross from astrophysics into cosmic sociology. Why now? Why this brief century when humans, after hundreds of thousands of years in ignorance, have suddenly become capable of detecting and tracking such visitors? If 3I Atlas is natural, then the timing is another addition to the growing list of impossible coincidences. But if it is something else, an evaluation, a survey, even an archaeological artifact, then its synchronization with our technological maturity suggests design, a deliberate test, calibrated to appear when we were ready to notice. So 3I Atlas stands before us as an impossible object, a glowing paradox. Every cometary law says it cannot be what it appears to be. Every calculation says its path cannot be chance. Every probability collapses under multiplication. We are left with two options: stack coincidence upon coincidence until the tower sways under its own weight, or admit the possibility that intelligence has shaped what we see. The cosmos has placed the exam on our desk. The question is simple. Will we recognize the artificial when it wears the mask of the ordinary? The mathematics leave us with no safe refuge. Each anomaly in 3I Atlas backwards glow, missing molecules, impossible timing, strained natural interpretation on its own. Together, they crush it. To cling to coincidence is to stack dice until the tower topples. At some point, honesty demands the simpler conclusion: someone arranged the pieces. Imagine stumbling across a chessboard deep in wilderness, pieces locked mid-game. You could invent elaborate theories of wind gusts, animal nudges, improbable accidents, but the accumulation of improbabilities eventually forces recognition. Someone played chess here. 3I Atlas is our wilderness chessboard. Every orbital parameter calibrated with impossible precision. Every observable trait mocking our expectations. Every detail designed to whisper, "This is no accident." The anomalies are measured, documented, undeniable. The real question is whether we have the courage to acknowledge what they collectively imply, or whether we will continue, with increasing desperation, to explain them away until the moment of response is lost. Alan Turing framed this dilemma 75 years ago. His test was never really about machines, it was about us. Could we recognize intelligence when it wore a disguise? Today, the test has expanded to cosmic scale. What if advanced civilizations send probes cloaked as natural objects? What if they wait to see if we can pierce the mask, to determine whether our intellect is ready for conversation beyond our cradle? This is the Alien Turing Test hypothesis. Its elegance lies in restraint. Instead of announcing themselves with flashing lights or monumental ships, they present us with ambiguity. Objects that can be explained as natural if we cling to comfort, or as artificial if we dare to think beyond it. The test is not whether we can identify technology when it declares itself any child could pass that. The test is whether we can recognize intelligence when it hides in plain sight. Comets make perfect masks, familiar enough to soothe, variable enough to accommodate anomalies. A probe that mimicked cometary behavior but introduced subtle violations, tails pointing forward, chemistry missing, trajectories impossibly precise, would corner us into a choice: protect our paradigms or admit what is before our eyes. The curriculum seems carefully staged. ʻOumuamua in 2017 was the warm-up problem, a puzzle just strange enough to unsettle, just ambiguous enough to dismiss. Its acceleration without visible cause sparked debate, but creative physics, exotic ices, unseen jets provided cover. Then, almost as if by design, our own technology entered the syllabus. Musk's Tesla Roadster and NASA's Lost Centaur booster both masqueraded as asteroids until context revealed their true nature. They proved how easily artificial can appear natural, how our systems can be fooled. They showed us the mechanics of the mask. And then came 3I Atlas, the exam itself. No more subtle ambiguities. Its impossibilities are stacked so high that only intellectual contortion keeps the natural hypothesis alive. The backwards glow, the spectroscopic silence, the trajectory choreographed like mission planning, each anomaly a red flag, together a roaring siren. And yet, still, the majority response is comfort. Comet. This persistence in safe explanations suggests the test is probing deeper than data analysis. It is measuring our psychological readiness for paradigm shift. Do we cling to orthodoxy or demonstrate the courage to accept uncomfortable possibilities? Do we possess intellectual humility or only intellectual inertia? Timing strengthens the hypothesis. Oumuamua arrived just as we acquired tools for serious interstellar detection. 3I Atlas appeared when those tools had matured enough to document impossibilities with precision. If these visitors are random, then timing itself is another miracle layered atop all the others. But if they are designed evaluations, then the timing is exactly what we would expect. Each test arrives when we are ready to take it. The structure resembles pedagogy, not chance. First, basic concepts, then practice questions. Finally, the comprehensive exam. Each stage testing not only knowledge, but wisdom. Each anomaly calibrated to our biases, our incentive structures, our tendency to dismiss anomalies that threaten reputations. The sophistication of such design implies long observation, perhaps centuries, perhaps millennia, of patient study. They may know us better than we know ourselves. The stakes extend beyond astronomy. Success or failure in recognizing artificiality hidden in the ordinary may determine whether we graduate into dialogue with a larger community of minds or remain quarantined, classified as not yet ready. If we persist in denial, we risk branding ourselves as intellectually immature, too rigid to bear the weight of greater truths. And so the object drifts on, glowing backward, its every pass defying the physics we thought immutable. Each day, it remains a mirror, reflecting less about what it is and more about what we are. Whether we pass this test, whether we acknowledge what it represents, or retreat into the safety of denial, will reveal everything about our species' readiness to join the conversation that waits in the stars. Success in this strange examination would not be measured by telescopes or equations alone. It would be measured by humility, our ability to admit that what we see contradicts what we know. It would be measured by flexibility, our willingness to abandon cherished frameworks when the data refuse to fit. These are the qualities that fuel true discovery. Not calculation, not instrumentation, but the courage to let go of what feels safe. The Alien Turing Test, if that is what 3I Atlas embodies, seems calibrated precisely to measure such traits. Do we cling to comfort or embrace contradiction? Do we flatten anomalies into conventional molds or allow them to expand our conception of what is possible? It is less about detecting signals than about demonstrating wisdom. The observers, if they exist, remain invisible. Their presence is felt only through impossibilities left like breadcrumbs scattered across the dark. They do not announce themselves. They wait, watching our response, noting whether we reach for curiosity or for dismissal. In this light, the role of figures like Dr. Avi Loeb becomes illuminating. His persistence in entertaining artificial hypotheses, even under heavy professional fire, might be exactly what such an evaluation is designed to provoke. His intellectual courage demonstrates what advanced civilizations might be looking for. Not blind acceptance of the extraordinary, but a willingness to consider uncomfortable possibilities despite social cost. By contrast, the reflexive dismissal from mainstream voices reveals the other side of the ledger: rigidity, conformity, fear. And then came the infamous phrase, nonsense on stilts. Professor Chris Lintott of Oxford dismissed the idea of 3 Atlas as anything but a natural comet with rhetoric rather than reason. It was not an engagement with data, not a mathematical critique, but a gesture of institutional authority wielded as ridicule. That kind of phrase reveals something crucial. When faced with anomalies that threaten worldview, scientists are not immune to emotion. They defend, they mock, they deflect. The fortress of consensus becomes less about evidence and more about psychology. We have seen this script before. Alfred Wegener suggested that continents drift. His peers did not carefully dismantle his calculations, but ridiculed the very notion. Ignaz Semmelweis proved hand-washing could save lives. His colleagues did not celebrate but destroyed him. In each case, paradigm, threatening evidence was met first with mockery and dismissal. Only later, often after wasted decades, did reality force admission. But here, the timeline may not be so forgiving. If 3I Atlas is indeed a test, if its anomalies are invitations rather than accidents, then our response window may be finite. We might not have the luxury of 50 years of ridicule before conceding. The clock ticks as the object continues its impossible passage, glowing backwards, defying chemistry, threading impossible paths through planetary encounters. The resistance itself betrays deeper anxieties. To admit 3I Atlas might be artificial is to admit we are not unique, that intelligence greater than ours has already passed this way. That is not merely a scientific disruption, it is an existential one. And so we invent ever more elaborate natural explanations, stacking improbability upon improbability, because it feels safer to preserve cosmic loneliness than to admit cosmic company. The sociology of consensus, usually hidden, becomes the decisive factor. Graduate students quickly absorb the lesson. Challenge paradigms and you risk your career. Professors eye tenure and know that controversy can derail it. Reputations, grants, and promotions all depend on coloring inside established lines. The result is systemic inertia, where the very structures meant to foster discovery become barriers to it. And so, the test continues. Each attempt to force 3I Atlas into natural categories, each rhetorical dismissal, each act of intellectual avoidance, becomes another data point in the ledger being tallied by whatever intelligence may be watching. The ultimate irony is that awareness of the test may itself be part of the exam. Do we realize we are being evaluated? Can we admit that our behavior is under observation, that our maturity as a species is being weighed not by what we know, but by how we respond to what we cannot explain? 3I Atlas thus ceases to be just an astronomical curiosity. It becomes an existential crucible. The anomalies it carries are not just puzzles of dust and light, but mirrors reflecting our readiness or unreadiness for contact. If we fail, it will not be because the data were insufficient. The anomalies are there, glowing, undeniable. It will be because we lacked the humility to see, the courage to admit, the wisdom to embrace the possibility that the universe is speaking. And if the examiners are indeed watching, then our species' cosmic future may depend on whether we can demonstrate that maturity in time. The test is already underway. The only unanswered question is whether we will recognize we are taking it before the opportunity to pass has slipped forever beyond our reach. Senior scientists guard their reputations as if they were fragile vessels. They avoid the speculative, even when speculation may be the only path toward truth. This self-preservation produces a culture of conformity that values safety over discovery, orthodoxy over imagination. It is no accident that paradigm-shattering ideas often come from outsiders, from those less tethered to the prestige economy of institutional science. Chladni was mocked for suggesting stones fall from the sky. Franklin was a printer and diplomat, not a professor, when he proved lightning was electricity. Einstein was a patent clerk when he dismantled Newton's cosmos. In the 3I Atlas controversy, Dr. Avi Loeb fits this archetype with uncanny precision. A tenured professor at Harvard, he possesses the rare security to question orthodoxy without immediate career annihilation. His willingness to propose artificial origins for anomalous interstellar visitors is exactly the intellectual courage paradigm shifts demand, yet institutional culture discourages. And the backlash he receives reveals what is truly being defended. Critics attack not just his analysis, but his competence, his credibility, even his right to speak. This is more than a dispute over data. It is a defense of worldview. The worldview in question assumes intelligence is rare, technology is primitive, and the universe is mostly silent rock and gas. To admit otherwise, to admit that probes may already be drifting through our solar system, that we are being watched, tested, evaluated, is to rupture the comforting illusion of human centrality. The intensity of the pushback betrays existential fear. And yet the irony could not be sharper. Skepticism properly applied should lean toward the artificial, not away from it. Natural explanations demand a stacking of improbabilities. Backwards glow, missing molecules, impossible timing, retrograde alignment, all multiplied into absurd unlikelihood. Artificial explanations require only one assumption that intelligence exists elsewhere. By every principle of parsimony, the artificial is the simpler hypothesis. But institutional skepticism has grown selectively applied, merciless against the extraordinary, indulgent toward natural impossibilities. That is not skepticism, that is bias. History reminds us how revolutions happen. Galileo's telescope revealed moons circling Jupiter when all dogma said they could not. Darwin's finches spoke of evolution when creation was considered immutable. Einstein's thought experiments broke the framework of absolute space and time. None of these breakthroughs emerged from the safe accumulation of normal data. They came from individuals willing to trust anomalies over orthodoxy. Real discovery is born in the cracks. 3I Atlas is just such a crack, except it is not a hairline fracture but a canyon. The backwards glow, the spectroscopic silence, the mathematically impossible trajectory. Each anomaly on its own strains explanation. Together they demolish it. Genuine skepticism should be thrilled by such evidence. Yet the establishment retreats into defensive postures, guarding paradigms rather than exploring possibilities. This is institutional science at its most brittle, protective, fearful, inert. And perhaps that is exactly what the test is measuring. If 3I Atlas is part of a curriculum, then the real exam question is not astrophysics but psychology. Do we show humility before anomalies or hostility? Do we explore the evidence or attack the messenger? Do we demonstrate readiness for larger truths or reveal our immaturity through denial? If observers exist, they are watching less the comet that is not a comet and more the humans who insist on calling it one. Step back, and a narrative arc comes into view. First came ʻOumuamua in 2017, slender and accelerating without jets, strange enough to intrigue, ambiguous enough to dismiss. Then came our own technology masquerading as natural objects, the Tesla Roadster briefly mistaken for an asteroid, the Centaur booster catalogued as 2020 SO until forensic orbital sleuthing exposed it. Each episode was a practice problem, teaching us how artificial can appear natural. And now arrives 3I Atlas, anomalies so pronounced they strain even our most creative rationalizations. This is no scatter of curiosities. It looks like progression, escalating difficulty, like a curriculum designed to stretch us toward intellectual growth. ʻOumuamua, the introductory course, solvable with strained creativity. Human technology, the practice exercises, teaching us humility about our own blind spots. 3I Atlas, the examination. Anomalies so blatant that continued denial reveals more about us than about the object. The question is not whether the test exists. The anomalies themselves are the exam paper on our desk. The question is whether we will recognize it before the proctor closes the book and walks away. When 2020 SO was unmasked as a Centaur rocket stage from 1966, drifting for decades under the gentle nudge of solar photons, something profound crystallized. Here was a human artifact mistaken for an asteroid, exhibiting the same non-gravitational acceleration that had once made ʻOumuamua so baffling. Radiation pressure was not speculation, it was physics, proven by aluminum skin and orbital detective work. In that moment, we inadvertently undermined our own refusal to consider artificial explanations for interstellar anomalies. The lesson was subtle, but devastatingly clear. Artificial can masquerade as natural, even when we know the technology intimately. Seen in this light, 3I Atlas becomes not an outlier, but the culmination of a sequence, an educational arc. Its behavior is so irreconcilable with natural models that explaining it away demands contortions that border on self-parody. To persist in calling it a comet is like insisting lightning must be meteorological static, long after Franklin's kite had drawn sparks from the sky. And yet, here lies the unsettling heart of the matter. The anomalies have not escalated randomly. They track with uncanny precision to our growing capabilities. Each visitor seems calibrated to the edge of our understanding, arriving exactly when we are capable of noticing. That pattern is not chance, it is pedagogy. ʻOumuamua in 2017 was the introductory puzzle. Its acceleration without jets could still be patched with exotic ice models. Its elongated proportions could be rationalized with improbable formation scenarios, ambiguous enough to dismiss, but strange enough to intrigue. Then came our own artifacts, the Tesla Roadster masquerading as an asteroid, 2020 SO tricking detection systems for months. These were practice problems, training us in humility, teaching that artificial can look natural, that physics like radiation pressure can blur categories. Now 3i Atlas has arrived, anomalies sharpened to the point of undeniability. The backwards glow, the missing chemistry, the mathematically impossible trajectory, each a red flag, together a blaring siren. To continue dismissing it as coincidence requires stacking miracle upon miracle, an edifice of improbabilities that collapses under its own weight, which leaves only one explanation: design. This realization transforms our role. We are not passive witnesses to cosmic happenstance. We are participants in an orchestrated sequence. Our strengths, our biases, our institutional habits, they are being measured. The test is not about physics we cannot solve, but about wisdom we may or may not possess. Can we recognize intelligence when it hides in plain sight? Can we abandon the safety of familiar categories? Can we demonstrate humility before data that fractures our paradigms? The evaluators, whoever they are, understand us unnervingly well. They know how much anomaly we can tolerate before our defense mechanisms snap shut. They know we protect paradigms rather than revise them, dismiss rather than explore. Each case has been tuned to maximize the tension between evidence and comfort. And now, with 3i Atlas, the tension is stretched to breaking point. The decision cannot be deferred much longer. This unified theory casts Dr. Avi Loeb's advocacy in a new light. What some colleagues frame as reckless speculation may in fact be prescient recognition of the pattern. His courage to voice artificial hypotheses is precisely the intellectual trait such a test would be designed to identify. By contrast, the mainstream's reflexive dismissal, its selective skepticism, its personal attacks, reveal the rigidity that might disqualify a species from larger participation. And perhaps that is the cruel brilliance of the design. The examiners do not ask us to build starships or decode alien languages. They ask only that we show honesty, that we acknowledge what is before us, even when it unsettles us, that we recognize the mask and admit there may be a face behind it. Recognition of the test itself may be part of the exam. Are we self-aware enough to know we are being evaluated? If so, then 3i Atlas is not just a comet, not just a curiosity. It is the final exam in a curriculum that began with ʻOumuamua. Our answers are already being written in how we frame our debates, in whether we dismiss or engage, ridicule or reconsider. Every paper filed under unusual Comet, every creative rationalization, every act of denial is another mark on our cosmic report card. The threads converge toward a single conclusion. We are being tested. We have been tested. And our performance will decide whether we graduate into a larger conversation or remain classified as immature, unready for contact. The official stance insists on certainty. 3i Atlas is a comet, an odd one perhaps, but a comet all the same. But the examiners, if they exist, will not grade us on our official positions. They will grade us on whether, at the moment the anomalies became undeniable, we chose comfort or truth. The turning point is here. The object continues its impossible journey, glowing backwards through the solar system like a lantern held up to our collective face. The question is not whether 3i Atlas is testing us. The question is whether we are ready to admit the test exists before the opportunity to pass it is gone. The official story holds firm. According to Dr. Alan Fitzsimmons of Queen's University Belfast, 3I Atlas is nothing more exotic than a comet peculiar, yes, but still explicable within the bounds of sublimation physics. The anomalies, he argues, can be folded into models of unusual composition, asymmetric heating, and rare orbital geometry. The backwards glow becomes a quirk of differential sublimation, though no such effect has ever been observed before. The missing molecular signatures are chalked up to an atypical ice chemistry, so water, poor as to border on impossibility. Each impossibility, in turn, births a new theoretical sub-branch crafted precisely to explain that particular contradiction, without acknowledging the larger pattern they collectively form. Academic ingenuity mushrooms, sprouting exotic natural models, all united by one goal: to preserve the comet hypothesis at any cost. Yet against this institutional conservatism stands Avi Loeb's artificial probe hypothesis. His approach reframes the anomalies not as geological puzzles but as engineering signatures. The backwards glow might not be sublimation at all, but optical or electromagnetic systems operating in ways our current physics cannot yet model. The trajectory, so impossibly precise, looks less like chance and more like navigation. The absence of molecular fingerprints ceases to be a problem. Manufactured objects would not be expected to produce cometary gas trails. Loeb's logic rests not on fantasy, but on precedent. Our own machines already exhibit behaviors that would look anomalous to outsiders. Solar panels alter reflectivity. Attitude control thrusters create unexplained accelerations. Antennas generate electromagnetic patterns interpretable only if you know their design purpose. If 2020 SO could masquerade as an asteroid, if the Tesla Roadster could appear on asteroid detection networks as a rock, then how much easier might it be for advanced probes to pass unnoticed through our blind spots? Within this artificial probe framework, interpretations fork into different branches. The conservative camp imagines reconnaissance, quiet scouts gathering data about solar, system structure, and planetary development. A more ambitious school suggests communication, with 3I Atlas itself designed as a message in disguise, legible only to those willing to pierce the mask. Others push the idea further into cosmic archaeology. Perhaps these are not scouts, but relics, technological fossils adrift for millions of years after their makers vanished, monuments to civilizations long extinct. And, inevitably, some speculate more darkly, what if this is advanced reconnaissance for something larger, mapping planetary environments and evaluating our capacities, a quiet military survey masquerading as astronomy? The most radical voices go further still, proposing that 3I Atlas might employ physics beyond our grasp, space-time manipulation, engineering that looks to us like magic because it transcends the limits of human technology. Every hypothesis brings its own evidence. The natural camp leans heavily on spectroscopic readings, orbital mechanics, and the assumed conservatism of nature. The artificial camp leans on patterns, precedents, and the absurd improbabilities natural explanations require. What emerges is not simply a scientific dispute, but a psychological mirror. For in these competing narratives we see reflected our assumptions about intelligence, our comfort with solitude, our readiness or unreadiness to accept a universe alive with minds. The pattern echoes earlier revolutions. Before plate tectonics, geologists split into hostile camps, inventing increasingly convoluted mechanisms to explain mountain ranges without letting continents drift. Before germ theory, physicians resisted the idea of invisible organisms, preferring familiar models of miasma, even as patients died. In each case, the real obstacle was not the evidence itself, but the comfort provided by existing worldviews. To accept mobile continents or microscopic killers was to upend the basic scaffolding of reality. 3i Atlas follows this script with eerie precision. The vehemence with which artificial explanations are dismissed, often with rhetoric rather than reason, reveals that more than astrophysics is at stake. We are defending a cosmology, one that rests on human centrality, on the rarity of intelligence, on a universe that is mostly empty, mostly dead, mostly safe. To admit otherwise is to unsettle our place within it. And so, we cling to natural explanations even when they require independent miracles stacked atop one another. But mathematics does not bend to psychology. The improbabilities remain what they are. Each anomaly documented, each trajectory calculated, each absent spectrum measured. No flourish of rhetoric can erase those numbers. At some point, evidence must weigh heavier than comfort. Scientific integrity demands that when natural explanations require a string of impossibilities, and artificial explanations require only the reasonable assumption of intelligence elsewhere, we let the simpler hypothesis carry the day. Instead, we do the opposite. We display a selective skepticism merciless toward artificial possibilities, indulgent toward natural impossibilities. This inversion is itself the anomaly that may matter most, for if 3i Atlas is indeed a test, then the real data being collected is not spectral lines or orbital elements, but our response. Do we demonstrate curiosity, humility, flexibility, or do we retreat into the fortress of denial? The observers, if they exist, must find our answer written not in equations, but in the posture of our refusal. Selective skepticism is not skepticism at all, it is bias disguised as rigor. Faced with 3i Atlas, humanity reveals this bias with stark clarity. Each anomaly, the backwards glow, the spectroscopic silence, the mathematically impossible choreography is documented, measured, undeniable. Yet rather than weigh the evidence evenly across all hypotheses, we lean toward the ones that protect our worldviews. The possibility of artificial origin is dismissed out of hand, while natural explanations requiring multiple independent miracles are embraced as if they were parsimonious. If this object is indeed an evaluation, then perhaps this very reflex is the subject of study. The test is not in orbital mechanics or spectroscopy, but in psychology. How do we respond when the universe confronts us with impossibilities? Do we reach for intellectual humility or defensive denial? Do we expand our frameworks or contort them until they break? Every published paper, every official dismissal, every rhetorical deflection becomes part of a cosmic dataset documenting not our technical ability, but our maturity. And the emerging answer is grim. Our collective behavior suggests failure. We are failing to recognize the most obvious artificial visitor in human history. Faced with anomalies that scream design, we insist on coincidence. Confronted with physics that defy natural explanation, we invent increasingly baroque natural models rather than admit the simpler alternative. This is not scientific caution, it is cognitive rigidity, it is fear. The consequences extend far beyond astronomy. The pattern repeats across every existential challenge we face. Climate change confronts us with overwhelming evidence, yet we cling to incremental fixes that preserve our lifestyles. Artificial intelligence presents risks we acknowledge only in theory, while forging ahead without safeguards because restraint feels too uncomfortable. Pandemic preparedness, nuclear deterrence, asteroid defense, the same pattern echoes. Evidence denied, tail risks dismissed, uncomfortable revisions postponed until too late. 3i Atlas is more than a comet or probe. It is a mirror. In its impossible glow, we see reflected our greatest weakness, the inability to abandon comfort when evidence demands transformation. The intelligence being measured is not our capacity to build telescopes or calculate orbits. It is wisdom, the courage to say, "We do not understand," the humility to let go of anthropocentric assumptions, the willingness to imagine realities larger than our current frameworks. Failing this exam does not simply postpone cosmic citizenship, it signals vulnerabilities that threaten our survival here on Earth. Species that cannot revise their worldviews in response to new realities do not endure. They are eliminated by those very realities, their technological sophistication no shield against intellectual immaturity. If 3I Atlas is an exam, then the verdict so far is clear: not yet ready. Still clinging to old cosmologies, still explaining away rather than explaining toward. Still protecting the fragile comfort of human centrality rather than facing the vast and unsettling possibility that intelligence surrounds us. And yet the object remains. Each day it glows impossibly forward, carving its path through the solar system. Each day offers us another chance to change our answer. The exam is not over. The question remains on the desk. Will we choose courage or comfort? Will we pass into dialogue or remain in silence? The decision, as always, rests not with the stars, but with us. This, perhaps, is the most dangerous evolutionary balance imaginable: technological sophistication without the wisdom to wield it. Humanity sits in this precarious configuration now. We can build machines that threaten the planet's climate, develop algorithms that may outstrip our control, split atoms with enough force to destroy cities. But we cannot yet reliably expand our thinking beyond the narrow boundaries of comfort and convention. If cosmic observers exist, they may be documenting not the rise of a civilization, but its faltering step towards self-elimination, the moment when technological adolescence collides with psychological immaturity. And yet the exam is not finished. 3I Atlas continues its impossible drift through our solar system, a glowing paradox, offering us daily opportunities to revise our answers. Every time we retreat into coincidence theory, inventing new miracles of physics to shield ourselves from the obvious, another red mark is added to our report card. But every time we dare to consider what the evidence actually suggests, another possibility opens: redemption through intellectual courage. The test is ongoing, and so is our chance to pass. The choice before us is not merely about categorizing a strange object. It is about whether we can evolve beyond the cognitive limitations that have haunted us since prehistory. Can we learn to see anomalies not as threats, but as invitations? Can we summon the humility to abandon cherished assumptions when reality insists otherwise? These are not just scientific questions, they are existential ones. The intelligence behind 3I Atlas, if intelligence it is, may be offering precisely the kind of paradigm expansion that our survival demands. Imagine the scenario brought closer to home. You sit in your backyard one quiet evening and notice a figure at the edge of your property. They do not threaten, they do not speak, they simply watch. What do you do? Pretend not to see them, hoping invisibility works both ways? Convince yourself they must be a neighbor, a delivery worker, anyone but a stranger? Or do you acknowledge them, take the risk of saying, "Hello"? This is humanity's present posture toward 3I Atlas. We see the stranger in our cosmic backyard. We know their behavior does not match the explanations we offer ourselves. And yet we persist in pretending, in naming them Comet, as though the word itself restores order. But what if the stranger is waiting for acknowledgement? What if the test is not about our ability to calculate orbits, but about our willingness to recognize presence? to say, in Avi Loeb's simple formulation, "Hello, welcome to our neighborhood, peace, asterisk." That single act would represent the courage to abandon anthropocentric assumptions, to admit that we may not be the adults of the cosmos, but children discovering adulthood exists. And that is the psychological challenge. Can we bear the ego dissolution such contact would demand? Humanity's greatest fear may not be invasion but irrelevance, the recognition that our proudest technologies are sandcastles compared to architectures built on million-year scales. To accept this is to accept our place as learners, not masters. To resist is to cling to illusions that could destroy us. 3. Atlas, then, is both astronomical anomaly and psychological mirror. Our responses, creative physics to explain away the backwards glow, statistical miracles to preserve natural categories, dismissals of artificial possibilities, are the answers we are penciling on a cosmic exam. Each act of denial reveals our rigidity. Each glimmer of curiosity reveals our potential. And the implications stretch far beyond astronomy. The same intellectual flexibility required to recognize an artificial visitor is precisely what we need to navigate our other existential crises. Climate change, artificial intelligence, nuclear risk, pandemic threats, all demand the courage to abandon familiar assumptions in favor of paradigm shifts. A civilization capable of recognizing intelligence in the skies may also be capable of confronting its own terrestrial challenges with the wisdom they demand. But the clock is ticking. 3i Atlas maintains its impossible glow each day, a reminder that the exam is still underway. The observers, if they exist, remain silent, recording our reactions, assessing whether we are ready for participation in something larger than ourselves or destined to remain subjects under cautious surveillance. The stakes are civilizational, the implications existential. The question could not be more direct. Are we ready to recognize that we are being tested, or will we continue pretending that the stranger in the yard is nothing but a shadow, a neighbor, a trick of the light? Our choice may determine whether we graduate into a larger cosmic community or remain a brilliant but brittle species, undone by its own refusal to see. A civilization that insists on explaining away impossibilities rather than facing them is not merely cautious, it is fragile. Such a species may wield extraordinary tools yet lack the wisdom to survive the very forces it unleashes. The lesson of 3i Atlas is not confined to astronomy. It is a stress test of viability, probing whether we are capable of intellectual honesty when reality refuses to conform. The exam question could not be clearer. Are we wise enough to recognize intelligence when it reveals itself not through fireworks and radio beacons, but through carefully orchestrated contradictions? Are we humble enough to admit that our models of the universe might require expansion as radical as those that followed Copernicus, Darwin, or Einstein? These qualities, humility, courage, flexibility, are not cosmetic virtues. They are the difference between civilizations that graduate to cosmic significance and those that falter against the evolutionary filter, extinguished by their own rigidity. If the designers of these interstellar enigmas are real, perhaps they are watching for precisely this distinction. They may be less concerned with whether institutions conform than with whether individuals, scattered across our world, can show the courage to dissent from orthodoxy and embrace anomalies as signals rather than threats. Dr. Avi Loeb embodies this fragile hope. His willingness to articulate uncomfortable hypotheses proves that not all intellectual courage has been strangled by professional risk aversion. Beyond academia, the public itself seems more open than the institutions that claim to represent knowledge. Ordinary people grasp instinctively that objects glowing forward instead of backward, defying chemistry and mathematics alike, cannot be explained away as mere odd comets. Their wonder, their curiosity, may prove more adaptive than professional skepticism. Perhaps the evaluators, if evaluators exist, are not looking for unanimity, but for sparks of courage. Perhaps the point is to map our spectrum of responses, documenting both the rigidity that confines us and the flexibility that might save us. Meanwhile, 3I Atlas continues its impossible choreography, trailing not a comet's expected plume, but a riddle scrawled in dust and light. Every day that it persists in violation of natural law is another entry in the cosmic ledger, another line in the exam script we are unconsciously writing. Each cometary paper filed in journals becomes a recorded failure of institutional imagination. Each whisper of possibility from curious voices becomes a potential credit toward redemption. And so the central question hovers, haunting as the object itself. Are we passing? Can we demonstrate the evolution of thought that contact requires? Do we have the wisdom to recognize intelligence when it reveals itself not with trumpets but with paradox? The stakes are everything. Our admission into a community of minds, or our relegation to continued isolation, may depend not on our rockets or our telescopes, but on our honesty. The observers, if they exist, continue their vigil. The test remains in progress, and the clock ticks with each impossible day that 3I Atlas glows against the flow of physics, each orbit a reminder that time to answer is finite. Perhaps even now, the next exam question is already inbound, written in trajectories we have yet to notice. We must prepare, for whether we admit it or not, the test has begun, and our grades may determine the future of our species. The question that will not let us go is the simplest of all. Will we finally acknowledge we are being examined? The fate of our civilization may hinge on the courage to answer yes. A civilization that insists on explaining away impossibilities rather than facing them is not merely cautious, it is fragile. Such a species may wield extraordinary tools, yet lack the wisdom to survive the very forces it unleashes. The lesson of 3180 ATLAS is not confined to astronomy. It is a stress test of viability, probing whether we are capable of intellectual honesty when reality refuses to conform. The exam question could not be clearer. Are we wise enough to recognize intelligence when it reveals itself not through fireworks and radio beacons, but through carefully orchestrated contradictions? Are we humble enough to admit that our models of the universe might require expansion as radical as those that followed Copernicus, Darwin, or Einstein? These qualities, humility, courage, flexibility, are not cosmetic virtues. They are the difference between civilizations that graduate to cosmic significance and those that falter against the evolutionary filter, extinguished by their own rigidity. If the designers of these interstellar enigmas are real, perhaps they are watching for precisely this distinction. They may be less concerned with whether institutions conform than with whether individuals, scattered across our world, can show the courage to dissent from orthodoxy and embrace anomalies as signals rather than threats. Dr. Avi Loeb embodies this fragile hope. His willingness to articulate uncomfortable hypotheses proves that not all intellectual courage has been strangled by professional risk aversion. Beyond academia, the public itself seems more open than the institutions that claim to represent knowledge. Ordinary people grasp instinctively that objects glowing forward instead of backward, defying chemistry and mathematics alike, cannot be explained away as mere odd comets. Their wonder, their curiosity, may prove more adaptive than professional skepticism. Perhaps the evaluators, if evaluators exist, are not looking for unanimity, but for sparks of courage. Perhaps the point is to map our spectrum of responses, documenting both the rigidity that confines us and the flexibility that might save us. Meanwhile, 3-1 Atlas continues its impossible choreography, trailing not a comet's expected plume, but a riddle scrawled in dust and light. Every day that it persists in violation of natural law is another entry in the cosmic ledger, another line in the exam script we are unconsciously writing. Each cometary paper filed in journals becomes a recorded failure of institutional imagination. Each whisper of possibility from curious voices becomes a potential credit toward redemption. And so the central question hovers, haunting as the object itself. Are we passing? Can we demonstrate the evolution of thought that contact requires? Do we have the wisdom to recognize intelligence when it reveals itself not with trumpets, but with paradox? The stakes are everything. Our admission into a community of minds or our relegation to continued isolation may depend not on our rockets or our telescopes, but on our honesty. The observers, if they exist, continue their vigil. The test remains in progress, and the clock ticks with each impossible day that 3i Atlas glows against the flow of physics, each orbit a reminder that time to answer is finite. Perhaps even now, the next exam question is already inbound, written in trajectories we have yet to notice. We must prepare, for whether we admit it or not, the test has begun, and our grades may determine the future of our species. The question that will not let us go is the simplest of all. Will we finally acknowledge we are being examined? The fate of our civilization may hinge on the courage to answer yes.